Welcome everybody. This will be a rapid review of introductory Java aimed at the students taking my AP class next year. I'll present it as if you haven't seen this material before, but hopefully this will all be review for you. It'll also go fairly quick, so I'd recommend pause when you need to and refer to the written reference materials I've given you if you need more guidance. I'm assuming you've watched my first video about how to install Eclipse on your home computers, so let's start by creating a new Java project called Summer Work. You'll see it here on the left-hand pane. SRC stands for source or source code. That's the programs we're going to type. We'll go to new class. If you remember, class is the name for the program you're writing. And I'll call this set1 because this will be all about the things you need to know for problem set 1. Uncheck public static void main because I want us to type this in ourselves. All right, I'll double click here on this tab so that we can see it large enough. Let's build up step by step the simple program that we have in problem 4. You can type as long as I go if you'd like. Class, remember, is the name of it refers to a program that we're writing. Set1 is the name of our program. You can't just change this to whatever you want. If I changed my mind and wanted to call this set2, it's not going to work because this name has to match the file name that we have, set1.java. If you want to rename your code, in the window here you can right click and say refactor rename, which is also Alt-Shift-R. Okay, the program will start executing inside what's called the main method. So you have to create the main method to start with. Let's do that. Public static void main, string with a capital S followed by the square brackets, and then an opening curly brace and a closing curly brace. Okay, this defines the main method, which, as I said, is where the program starts running the code line by line. This first line is called the method signature. It's what tells us the name of the method and if the method takes any inputs or has any outputs. You'll learn more about that later. For now, know that main is the name of the method, and this is a special method that each of your programs has to have because it's how the computer knows where to start executing. All of your lines of code, what it is that you want the computer to do, have to go in between these two curly braces. Curly braces like this define what's called a block of code, which is just a sequence of Java statements. All right, let's start with something simple. Let's just print something to the screen. The way you display something to the screen is by saying system.out.println, and then whatever you want it to say is going to go in between these two parentheses inside quotes. So I'm going to say, welcome to our miles to feet conversion program. And then each line has to end with a semicolon because that's actually how Java tells that your command is over. Humans are going to read it by putting the next command on the next line, but the way the computer knows is with the semicolon. If I run it, you can see it just displays welcome to our miles to feet conversion program. Perfect, just what we wanted. Okay, so let's create some variables. I'll say double miles equals 23.1. So just like in math, in computer science, you can have variables, which are symbols that represent other information. Unlike math, you can store all kinds of information inside your variables, and your variables don't have to be called things like X. They can be called entire words. Generally, it's good practice to name your variables after what it is that they are containing. So because this is supposed to represent some number of miles, I've called it miles. What's this double about? Well, because you can store lots of different kinds of information, when you declare a variable, initially, you have to tell the computer what's the name of your variable and what type of information are you going to store inside of it. So I can also declare another variable here called feet. This is a variable declaration. It says the name of the variable, and then double says what type of information is it going to hold. That's called the data type. Double is a special data type that represents real numbers or numbers with decimal parts to them. Yeah, maybe that's enough about that for now. So this line declares the variable feet to hold doubles. This declares the variable miles to hold doubles, and the equal sign also assigns a number to it. Unlike in math, equals, you should think about it as meaning assignment. It means it's going to evaluate whatever's on the right-hand side and store it inside of whatever's on the left-hand side. So in other words, this is going to store the number 23.1 inside the variable miles. I can also assign variables values after I've created them. So I could say feet equals 12, and that will save 12 inside feet. Notice that I cannot do this. This doesn't make any sense because equals means assignment. It means it's going to take this number and try and store it inside there. You can see 12 is underlined in red. That's because you can't store things inside numbers. They're not variables. Indeed, it says the left-hand side of an assignment must be a variable. So you see sometimes when there's a syntax error, also called a compile time error here, it will tell you what the problem is. Sometimes it's hard to understand those messages, but I'll tell you about them as we go along. All right, so far we have created some variables. This is called a comment. See how it's in green? That means the computer's going to ignore it. This is just for the programmer to write notes to themselves about what are the different parts of the program that they're writing. So I created some variables. Now I'm going to calculate the number of feet, and then finally I'm going to display the number of feet. Okay, so if I want to calculate how many feet are in this many miles, I know there's 5,280 feet per mile, so I'll say feet equals the number of miles I have times 5,280, and then a semicolon because that's the end of the line. So what this does, again, is it evaluates this entire expression on the right. Whatever number this results in gets stored inside feet. Okay, well, how do I display variables? I can say system.out.println. If I say feet in quotes, that's actually going to display the word feet. I want to display the contents of the variable feet. So to do that, I could leave the quotes out, and then it's going to try and interpret this as a variable. So I could do this. If I run it, you see welcome to our miles to feet conversion program, and then it displays a number. That's not a very helpful output message, so let's make it a little nicer. There are this many feet in that many miles. And now when you run it again, you'll see there, this many feet in that many miles. Whenever you're writing programs, you should aim to have the output be as comprehensible as possible. All right, so notice what's happened here. Here I have both text combined together with the values of variables. Remember how double is the name for the type of information that's numbers with decimal parts? There's another name for the type of information that text is. We call it a string. So this is a string. So the println statement here is displaying both strings and the values of our variables. The plus operator here, if you were going to use it with numbers, adds numbers together. If you use the plus operator with a string, it does what's called concatenating them, which means it has first one string followed directly by the next string. So it just glues them together end to end. So what's actually happening in this example is it starts with there are. Feet is not a string, but when you add it together with a string, it does something called casting, which means that it will treat it as if it's a string, which means treat it as if it's text rather than a number. And so it concatenates the text together. And you see we can do this as many times as we want. Whenever you want to concatenate two strings together, you insert a plus sign in between them. Okay, so to review, we've got the pieces. Most programs are going to start out by declaring variables and initializing them by assigning them some values. Then you're probably going to do some calculations with them of some kind. And then you're probably going to display the output. More complicated programs have more complex variations on that theme, but that's a good way of thinking about the overall basic structure of your programs. So what else can happen? Double is what's called a primitive data type. You can read more about that in the reference sheet. Other primitive data types that are in the AP subset of Java are int, which represents an integer. Let's see, float is not. Boolean is. So I could say Boolean has user clicked. Boolean values can only be true or false. Notice how false highlighted in purple here? That means it's a reserved word. So you couldn't name a variable false because false is a special value that gets stored inside Boolean variables. Boolean variables are all often used to remember whether or not something has happened, like has a user clicked the mouse. These are also sometimes called flags, because the idea is you could use a flag to communicate to someone far away whether or not some event has happened. If you put the flag up, that's like saying, yep, the British are coming. And if you put the flag down, that means everything's okay still. So same thing, if you were to assign true to the Boolean variable, that's like you could think about it like a flag. Like, this variable is now storing the fact that the user has clicked the mouse, and false otherwise. You can do lots of different mathematical calculations. So the star operators for times, you could do divided by for division, you can do plus, you can do minus. The order of operations is the same as in mathematics. And if you wanted to, you could group things with parentheses. You don't have to group, here, let's do, I don't know, yeah, let's do this, times 3. So this means something very different than if you remove the parentheses, because in that case, the multiplication would happen first. I'll talk about the math library later. So print statements, this is how you display things to the console. This is called println because this ln here stands for line, and the reason why is because it displays whatever string you have as the input here. And then once it's done displaying, it will move the cursor to the next line, as you see in our example. There's another print statement just called print, and what this does is it displays whatever the string is, but it doesn't move the cursor to the next line. So even though I have two separate print statements here, they're going to appear on one line when I run it, because when I get to the end of the first print statement, because it wasn't print line, it didn't move the cursor down. You can also insert your own new line characters. If I use \n, the computer will interpret that as meaning move to the next line. So here you see welcome to our miles to, but then it moved to the next line and it says feet here, and the reason why is because it interpreted the \n as a new line character. You can have as many of those as you want back to back. \t means the same thing as tab. If you want to actually display a backslash inside your string, you have to use a double backslash, and that will display as a single backslash. Let's review what you should know so far. You should know the following data types: int, which stores integers; double, which stores real numbers; boolean, which can only store true or false; and string, which stores textual information. There's other data types in Java. We won't be using them. These are the ones that are used in the AP test. Actually, I'm sorry, we will be using them, but these are the ones that are used in the AP test. You can see a full list of them in the handout that I've given you. You can also use the following mathematical operators: multiplication, division, addition, and subtraction. You should know the difference between print statements and print line statements and how to use them. You should also know how to use them to display strings by themselves, as well as how to concatenate strings together with the values of variables. You should know the following vocabulary. You should know what the main method is. You should know what it means to declare a variable versus assign a variable a value versus initialize a variable. And you should know what comments are and how to create them. A final thing you should know about is you will definitely make typos as you are creating your programs. And so it's going to be helpful to recognize when that happens and how to fix it. So let's go backwards. Okay, here we are at our program. Let's just break a whole lot of stuff and see what happens. So let's pretend I want to rename my program from set1 to set2. If I change this to set2, you see it underlines in red, and it says the public type set2 must be defined in its own file. The reason why is because this class name has to be the same as the file name in which it's defined. So this is set1.java, so this has to say set1. It can't say something different. Let's pretend that I made this s lowercase s. Okay, you see it says red, and when I hover over it, it says string cannot be resolved to a type. What that means is it's expecting a data type, and we know string with a capital S is a data type. String with a lowercase s, it doesn't recognize what that means. And if I try and run the program, it says an exception has occurred, and it doesn't really give me any information. So let's fix that. Let's say I have a capital M for my main. You see there's no red. You do see a yellow here. This is a warning, not an error. We'll talk about warnings in a minute. So there's no problem here, seemingly, but when I press play, it says main method not found in class set1. The reason why, as I said, main is a special predefined method. It's where the program looks to start executing. But it's only looking for a method called main with a lowercase m. If you named it with an uppercase m, that's a totally different thing, and so it doesn't know where to look to run your program, which is why it doesn't run when you press play. What if we left out double? What if I just said feet? Now you'll notice feet is underlined, and it says feet cannot be resolved to a variable. You're going to see this one probably a lot. What it means to say it can't be resolved to a variable is it doesn't recognize it as a variable you've declared, because we didn't actually declare it up here. This is going to be common when you write long programs and you misspell your own variable name further along, or you get the capitalization wrong. Most programmers declare all their variables at the top of the method, because that's a convenient place to look. It also kind of sets you up for what information are you going to use later on in the method. So I fixed the problem again by declaring the variable. Let's look at what this warning says. The value of the local variable user has clicked is not used. Well, that's true. I declared it here, I assigned it a value, but then I never used that the variable anywhere in the rest of my program. So it's just warning me I created a variable that I'm never using. Is that an error? No. Which is why it's underlined in yellow. It's just warning me that maybe I'd intended to use it and forgot. You can still run your program no problem, even if there are warnings, but it's good to just check them out to see what they're warning you about. What else could happen? I already mentioned that you can't reverse the order of these two things. Equals sign means evaluate the expression on the right, whatever it's equal to, you assign that to the variable on the left. If I use a lowercase s here, it doesn't recognize system, so that has to be an uppercase S. A very common beginner mistake is leaving out the plus sign. So it says there are feet, but it says syntax error on token feet, delete this token. So what it's saying there is it doesn't think that this is the sort of thing that can come next after the string, and the solution it's suggesting is that you just delete it. So I could just delete it. Oops, if I just deleted it, now it's going to work again, but it's not going to do what I want it to do. Beginners, lots of beginning programmers try to get rid of all the red however they can. Your goal is not just to get rid of the red. Your goal is to make a program that actually does what you want it to do. So you can't just make changes at random that eliminate those compile time errors. You have to actually think about what do you want the program to be doing, and if you make a certain change, is it still doing what you want it to be doing? Okay, I think I've said enough about that. Okay, what if I want to do more complex mathematical operations than the four simple ones? There's a special library called the math library, which has a lot of mathematical functions that are more familiar from your graphing calculator or scientific calculator. They do things like exponentiation, they've got trig functions, and they've also got some other ones that aren't on your calculator but are useful for programming. Let's just show you, I just want to show you how to use a couple of them. Let's just have a number n equals something, some other number a. So in order to use the math library, you have to say math with a capital M, and then dot, and then you see it pops up a box, and it lists a whole bunch of methods that are available to you. You might be confused by my use of the word method. Method is really, you can think of it sort of like a command. Some commands other people made, some commands are commands you're making. So the main method is a command that you're making for your program, and it's the command that gets run to start your program. Inside the math library, we've got all these other commands that actually give you back values because they are designed to calculate things for you. So let's say I want to do the cosine function. If I do math.cosine 3.24, it will return the cosine of this angle, where this is interpreted in radians. I can put variables in here as well if I want to. So I could say n, and that would calculate the cosine of 3.2. I can do square roots if I want to, so math.sqrt does a square root. And I can also put in expressions here as the input. So whatever is on the inside of the parentheses for square root is going to get evaluated first before that value gets passed to square root in order to do the calculation. So you can have arbitrarily complicated expressions inside here if you want to. Okay, I'm not going to say anything more about the math library. You might be wondering, how do I know about how all these functions work? How do you even know what functions are available? If you go to, well, here, let's just close this tab. So if you go to Google and you type Java API math, API stands for Application Programmer Interface. You can sort of think of it like a manual for how to use different parts of the Java programming language. So if I click here, this is sort of the documentation for the math library, and you can read probably a lot more than you want to know about it for right now. So let's make this be on the screen. You got to learn how to read these. There's a lot of text here, and you're not necessarily supposed to read every sentence with equal importance. So here it's saying the math class contains methods for performing basic numerical operations, and it's going to tell you a little bit more about, in general, what's the math class doing. If you scroll down to where it says method summary, remember method means command, so this is a summary of all of the different commands that the math library makes available. So ABS returns the absolute value of a double that gets passed as input. Scrolling down a little bit more, we see tangent, we see square root, round, so the round method returns the closest int to the argument with ties rounding up. Argument is just another word for input. It's the value that you pass to round that you want it to do something to. So for any part of the Java language, you can always look up the API and often learn interesting things that you didn't know before. All right, here we are back in our program. Okay, let me teach you 2 different ways to get user input. Let's write a program that greets us by name to start with. So let's see, my name is a string. So I'll create a string variable called name to hold my name. And then I'll want to display it eventually. Welcome. And then your name. Okay, so all that remains is in the middle here, I need to have the user type in their name. All right, so how do we do that? Let's do this way first. So name equals JOptionPane.show input dialog, enter your name. All right, so JOptionPane is an object that will let you open a little window with a text dialog in it that you can type into. This is the prompt that will display in the window, and whatever you type will get saved into this string variable. So here we are. Enter your name, Wally, and then it says, welcome, Wally. So that's pretty straightforward. It's a little less straightforward if we also want to have the user enter numerical information. So let's have us enter the age also. So I can't do this. It would be nice if I could, but not possible. Oops. Show input dialog, enter your age. This would make sense. It's popping open a window. We enter the age. We type in numbers, and the numbers save into the integer age. Well, unfortunately, whatever you type in, even if you type in numbers, gets stored as text information. So it has to be stored inside a text variable. I'm going to create a new text variable called response to hold, it's just a temporary storage location for whatever it is we typed. And then if I want to actually use the age as a number, I have to take the text information and convert it into a number variable. Here's how you do that. Because I want to convert it to an int, I'm going to use the integer class. I'm going to say integer .parseInt, and then response is the text that I want to parse. So what's happening here is integer is a special object that, well, it's a special class that does things with integers. parseInt is a special command that takes text as input, tries to interpret it as a number, and gives us an int as an output. This is the input to the text command. This is the input to the parseInt command, and it's whatever text we just typed. So if we type the number 5 stores as text information here, then we take that text information, it interprets that textual number 5 as an actual number 5, and it saves it in age. And now we can say, you are days old. That's what happens when you don't use any units. So your name is Wally, type your age, 33. Welcome, Wally, you are 33 days old. Okay. So that's cool. Let's do a different way of getting user input, not using JOptionPane. This way of getting user input will use a special object called Scanner. So I'll say Scanner input. Notice how this is the exact same structure, this is the exact same pattern as declaring any other variable. This declares a variable that's named age, and it stores ints. Named name stores text. Here, the variable name is called input. It's storing a special kind of data called scanner. See how scanner has an uppercase letter? That means it's an object rather than a primitive data type. Int is a primitive data type, which means it just stores a simple kind of information. Objects are more complex. They store not only information, but they can also run commands for you. So a scanner is a special kind of object that will scan things, like it can scan the contents of a file, or it can scan your keyboard input. And it can run commands like return what that input is. So just creating the variable doesn't actually store anything inside the variable. Right now this variable is empty. So I actually have to create a new scanner object to store inside the variable. The way you create new objects is with the new command. So you say new, and then you give it the name of the type of thing you're trying to create, so new scanner. And then you have parentheses, and inside the parentheses is the input to whatever it is that you're trying to make. The scanner expects a specific kind of input. You have to tell it what is it that you want it to be scanning. And I want it to scan system.in. Okay, you see there's red, which means there's still compile time errors. It says scanner cannot be resolved to a type. If you remember from before, this means it doesn't recognize this as a data type. If I click import scanner here, what happened? Oh, here we are. If I click import scanner, it's added this line at the top of the program, import java.util.scanner. This is telling the program that you want to bring in the code that defines the object scanner so that you can use it in your own program. Okay, now that I have my scanner object, I can actually use it to scan for user input. So I want to save whatever the user types in into name. So I'm going to say input dot next. Input is the name of my object. Next is the command I want it to do for me. This pattern is always going to be the same. Whenever you want an object to perform some command for you, you're going to have the name of the variable, and then a dot, and then the name of the command it's supposed to perform. It's sort of like if you were going to order me around, you would say Mr. D dot grade my tests. So it's the same thing. You got to start with the name, then you have a dot, then you have the thing that you're asking it to do. Okay, next, that's a little obscure, but it's going to return a string for whatever you type. It's not going to pop up any prompt, though, so it's just going to wait there until the user types something. So it's probably better if we have a print statement that will tell the user what we want them to do. So type your name. So now if I run the program, oops, let's delete this part about the age. So now if I run the program, down here it says type your name, and if I select down there and I type Waldo, it says welcome Waldo. Let's use this same scanner object to read in my age. Now, because I already have the scanner object, I don't need to create a second scanner object. all I need to do is use the same scanner object I already have to read a new value in. So I'll say input dot next. Well, next returns a string. I'm trying to save an age, so I'm going to say next int. Oops. Because next int will interpret whatever I've typed as an integer automatically and save it into age. So now, wait, I still need a println statement because otherwise the users aren't going to know what to do. Type your age, and then you are. So now when I run it, it says type your name, Waldo, type your age, 23. Welcome, Waldo, you are 23 days old. So same program, just a slightly different way to get user input. Let's do one last thing. Let's learn about random numbers. So I want to have a randomly generated strength. So because I want to store my strength somewhere, I'm going to create a strength variable up here that will be an integer. But I want to generate my strength down here randomly. So I want a random strength between, well, I don't want to be too weak, so let's say between 2 and 10. And then I'll display it. Actually, I'm going to take away my age. You have a strength of strength. Okay, so how are we going to do this? I'm going to show you, well, there's several different ways to generate random numbers. I'm going to show you the most common way on the AP test, which is using the math library function random. All right, what does math.random do? It returns a double between 0 and 0.999999999. So sort of as close as you can get to 1 without actually being 1. Well, this is a problem because I wanted my strength to be an int. So let's cast it the same way that we did before. So now it's going to take this random number and it's going to chop off the decimal part. You can probably guess already what this is going to do. Type my name, Wally. Welcome, Wally. You have a strength of 0. Well, that's not surprising because this returned a number between 0 and 1. When I chop off the decimal portion, of course it's going to be 0. So let's do this. Let's multiply it by 10. Now, this isn't going to work the way that we expect it to. No matter how many times I run it, Wally will always have a strength of 0. The reason why is because it's doing this truncation before it multiplies it by 10. So I generate a random number, I chop off the decimal portion giving me 0, and then I multiply that 0 by 10. We really want to do this part first, so I'll group it in parentheses. Now I've got a random number between 0 and 9.99999, and then I cast that to an int. And if you run it, you'll see that I can get various numbers. Okay, well this still isn't between 2 and 10. Right now, this is between 0 and 9. Why 9, even though I multiplied by 10? Remember, this can never equal 1. The closest it can get to 1 is 0.99999. So if I multiply it by 10, now I'm anywhere between 0 and 9.99999. But when I chop off the decimal portion, the largest number I can be at is 9. So if I want to be between 0 and 10, I could multiply it by 11. So now it's between 0 and 10. But that's still not right because I want it to be between 2 and 10. So let me show you a technique for how to think about this. Let's start with the smallest number we want it to be. So I'll start with 2. So I want 2 plus a random number. I want this random number to be anywhere between 0 and 8. Because if it's 0, strength will be 2. If it's 8, it'll be 2 plus 8, which is 10. So if I have some number here, which can be between 0 and 8, that's going to produce the right overall value. Alright, so how do we make a number between 0 and 8? Well, if we wanted to, we could make a temporary number, n, the way that we just did a second ago. Oops. Math.random times, what did I want, 0 and 8? So now this is a random number between 0 and 8. which is being stored into n. And so now I can say 2 plus n, and that should be what I want it to be. It's a little silly to save this in a temporary variable n if I'm only going to use it on the next line. So let's just drop this part directly into the next line here. So now I'm starting at 2, I'm adding a random number between 0 and 8, and I'm saving that into strength. And so now when you run it, now when I run it, here I have a strength of 2. If I run it again, now I have a strength of 7. And this should just give me random numbers, strength of 4. Cool, that's it. I think that's everything you need to know for problem set 1.